Okay, so coming back to graphing exponential functions. And just like when we've learned to graph linear functions, we started by graphing using a table. That's what we're going to do with exponential functions. So when I click, it's going to move me to the next slide because there it is. So I'm going to make a table, and this one I'm going to make it a three-way table. This is going to be x values, the y values we get, or input, and then the output. And then in the middle, that's us plugging in to this function. All right, so the x values, I am choosing. I'm picking these. When I'm doing hand graphs, I tend to do 5 points just so I can get more of the shape, especially when it's something other than a line. And that is very important here. We are not creating lines. So we can't just do 2 points and shink, I draw through it. We need to know the shape. So -2, -1, 0, 1, and 2. Now, on your Math Excel, I don't think you have anywhere you're graphing, but this same method of finding a couple x values, plugging them in, and then matching them to your graph, that would be beneficial. All I'm going to do is, now that I've picked my 5 x values, I'm just going to plug them in. So I have 3 times 2 to the -2 power. Well, when I do that, I'm going to do my work off to the side so you can see how I do my work. 2 to the -2 power is 3 times 1 over 2 squared. So I've got 3 times 1/4, which is 3/4. So y is 3/4. And then I've got -1. So 3 times 2 to the -1 power. So that's going to be 3 times 2 to the -1 is going to become 3 times 1/2, because it'd be 2 to the first power, which is just 2, which will equal 3/2. So now we have 3/2. And I evidently did not space them out enough to have fractions. All right, 3 times 2 to the 0 power. Anything to the 0 is 1. So our y value is 3. 3 times 2 to the first power. 2 to the first power is 2, times 3 is 6. 3 times 2 to the second power, 2 squared is 4, times 3 is 12. And so then from here, we graph it. And so I totally should have picked one that went beyond and not just, so we're going to add on why I picked a first quadrant and not multiple quadrants. I don't know. So we'll say that's -1 and this is -2. That was my bad. Actually, I changed my mind. We're going to make this our y-axis. Y-axis. Just so that we have the grid. All right, so -2, I was at 3/4. So if this is 1, we would be about here. And then at -1, I was at 3/2. So that was 1.5. At 0, we were at 3. 1, 2, 3. At 1, we were at 6. 1, 2, 3, 4, 5, 6. And then we only we only go to 10 here, so 12 would be off. And so we're going to go with these 4 dots. Again, our curve will not touch. Oops, I went curvy. Our curve will not touch the x-axis. It flattens out at the x-axis. Okay, and I did my best. Normally I probably would have done sketch lines, lots of little sketch lines instead of trying to draw one big line, but that we graphed. It's graphed. Ta-da, done. If you're matching it, find x values and match, right? look at your graph, find an x value. The easiest x value is 0, but if they all have the same y-intercept, then you've got to move on to your like x is 1 or -1, something like that, to find your points. All right, example 4. Computer mapping software allows you to zoom in on an area to view it in more detail. The function f of x equals 100 times 0.25 to the x models the percent of the area the map shows after zooming in so many times. And so we're going to go by ones. Well, I lied again. We are going to go by ones, but I am going to push us in just... No, we should be fine. I just 0, 1, 2, 3, 4, 5. I just have to make some decisions. And we're going to count by tens going up. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100 clear up at the top. All right, so again, we're going to plug in. On this one, because it's software, we can't, and it says x is times that we zoom in. You can't zoom in negative times. So when we make our graph, x value is starting at 0. And I'm going to do 1, 2, 3, maybe 4. We'll see if I want to. And then we're going to plug in. So this is my x, and then we're going to find my y. So we're going to take 100 times 0.25 to the 0 power. Anything to the 0 is 1, so we end up with a y of 100. So we have a point at 0, 100 right here at the arrowhead. Unfortunately, I don't have a different color other than red. All right, now we're going to do 100 times 0.25 to the first power. So 0.25 to the first power is 0.25 times 1 gives us 25. So 1, 25. So 10, 25 right there. All right, 100 times 0.25 squared. So 0.25 squared is 0.0625. And we're going to take that times 100. I wouldn't round your decimals. I would keep them. And so for 2, we get 6.25. And so 2, there's 10. So this would be 5. So just above the 5. And if we plug in 3, we're going to have 100 times 0.25 cubed. So 0.25 cubed is 0.015625, right? Pretty big decimal there. We're going to take that times 100. And so we're going to, and I'm not going to graph all the way out to all the decimals. This is about 1.6. So 3 is just some itty bitty living space right here. At this point, like I said, I really don't want to see if I can find 4. We get super close. And so here are our dots. So when we zoom in one time, this is how close we've, gotten, right? So, or the percent at which we are. That, I believe, is it for our notes. And I'm sorry graphing takes so long, but it's the creating the tables and then putting the points onto the graph. And we all know how sometimes the writing tablet wants to be a pain. So until next time, 8th grade, thanks for hanging out with me. See you.